We want to make sure we draw a distinct line. When we talk about storage in general, we were talking about this last time. There's different ways we can store stuff, right? So where could we store things? We can store things in a file. We could store things in a database. So what's a database? So if we kind of go back through, historically walk backwards, in the early days of storing things long-term between runs of your program, what did we do? Well, we probably wrote stuff to a file because that's what our computers knew how to do. File systems have been around as long as computers have been around. So we'd open a file, we'd write it to the file, and no harm, no foul. What can you do with a file? So without thinking about NSUserDefaults for a second, what can you do with just a file? So I gave you a file and you wrote stuff to that file, and I told you later on to read that file. How can you recover stuff? What are operations that you can personally do on a file? Okay, so files we can write, read. Anything else? Well, I could probably delete a file. Well, in real life, we want to think of files as kind of like a dry erase board. We can walk up to it, we can manipulate it, we can add new stuff to it, we can erase stuff from it. I suppose we could decide to rip the dry erase board off the wall and destroy it if we would like to delete that file permanently. But do we always store our ideas or long-term things on a dry erase board? Why? Okay, so dry erase boards serve a purpose, but they're publicly readable potentially, right? I mean, if it's in your dorm room behind a door, maybe it's locked, but somebody came to your door, they could see it. Somebody could change it without you knowing, assuming they had physical access to it, right? What else? Are you limited to the types of data you can put on a dry erase board? To what? Well, anything you can produce with a dry erase marker, right? So squiggles, letters, and pictures that you hand drew, stuff. So you're limited, right? You can't take a movie you just shot on your iPhone and store it on a dry erase board. That doesn't work. So a dry erase board serves a purpose. It'll allow us to store textual data over periods of time, right? But it doesn't necessarily give us the flexibility we might want long term. Okay, so some of the problems with that dry erase board might be security and flexibility. Over long periods of time, how much stuff do you think you're trying to store on your daily life? How many things are you trusting your mind to remember versus do you trust external helper tools to help you remember? How about you use a calendar? Many of us use a calendar, right? Okay. How come we even use a calendar? Why don't you just keep track of all your appointments in your head?
Some of the things that look more important, and like calendars long term also.
You got a lot of crap going on, right? We can't trust ourselves to remember all of our appointments and things like that. A good example might be if you have a doctor's appointment 6 months from now, that your doctor made you schedule on your way out of your last doctor's appointment. Okay, chances are that's not going to be in your head for very long, right? Like maybe you'll remember like, oh, I think I have an appointment in December sometime. At some point, you kind of count backwards when the last time you were at the doctor. You're like, yeah, I think she wanted to see me in 6 months or something like that. So we have this concept, this problem-solving concept of needing long-term storage. And we use the right tool for the job. So those of you who use calendars, what kind of calendars do you use? Do you use your iPhone calendar? Anybody have like one of those little paper day planners? You seen those people carrying those around? Earlier we were talking about what happens if the electricity went out in the whole world. You know, what things would go down. You would lose your calendar thing, but the people with the daily planners, like, I'll still be there. This is all on paper. Okay, so, you know, we use different tools for remembering different types of things, right? Now, what are some features of your calendar for your iPhone that you like?
Reminders.
Okay, maybe it sets up a reminder. Does your dry erase board give you reminders? Okay, what else? Can you search for appointments?
Yep.
So I can search for doctor appointments on iPhone's calendar. I'm sure you can do it on Android's calendar too. No problem. Can you do that on your dry erase board? You can scan it with your eyes. So, let me see here. What about storage? How many things can you put in your calendar for iPhone? So as far as we're concerned, unlimited, right? How much stuff can you put on your dry erase board?
Probably unlimited. Depending how small you write.
Depending how small you write, or if you're willing to write over the top of other things. Would you agree that dry erase boards and iPhone's calendar are very different tools that both can store information? Calendar seems like it's more powerful, right? So we're going to say that dry erase board is kind of like a file. And we're going to say that that calendar is kind of like a database. So over the years, in the early days of storing stuff for our programs, when we needed to, a program closed and we were going to reopen it later on. This is back when we still had text-based programs. Graphical user interfaces didn't even exist. We were probably writing crap out to a file so that the next time we opened the program, we'd read it back in from the file to kind of pick up where we left off. And as users, we were empowered to decide the format we'd write the crap to the file. So maybe in the early days, what did you do? Maybe you wrote one piece of information per line. And you just knew that line 1 was this value, line 2 was this value, line 3 was this value. Okay, because you didn't have high performance computers. This idea of parsing strings and stuff like that probably wasn't going to go down. You know, if you needed to read in the number of records was on line 1. And it was just a number. Line 1 said 14. So when you write in line 1 internally in your program, you would have it hard-coded. Well, this is line 1, so that's number of records. Got it. Restore that variable value and move on with life. Well, then we started getting, as our computers got faster and our problems got more complicated, and the programmers started having more complicated, more complex solutions to these problems, we started coming up with ways of storing this data. So maybe the next step might be comma delimited. How many of you, if you are like an Excel file, if you export to CSV, heard of that before? A CSV file? What's a CSV file? What does it look like? Crap separated by commas. That's it. CSV file is crap separated by commas. All right, so somebody made this famous. So somebody way back when they were, upgrading the way they were storing stuff in files, they decided, you know what? If I put a comma between all my pieces of data, that might allow me to then piece it back out next time I load my program. That might be cool. And then a bunch of other people thought that was a good idea, and eventually they named a file extension after it. I don't know what CSV stands for, but comma separated values probably. Sounds legit. So, in any case, this would fall into another category of something that sounds more complicated than it actually is. Like, oh, it's a CSV file. Text file with things separated by commas. That's it. Okay, well, what's the problem with just separating things by commas? Why can't you just store everything that way? Why can't you just have everything stored in a file separated by commas? What's the downside to that? Well, there's one real quick, obvious downside. Can't store commas. So,
It's gonna take a while to find this stuff. It's not like separating groups.
okay, getting your data is going to require bringing all of the data into your program, right? So if you have, let's just say we're storing customer records, something like that. Let's say a customer record is, name, address, phone, email, something like that. So you might store it as Mike, 123 Main Street, 555 5555, something like that. That would be one line in your file. Next line would have a similarly formatted thing with a different user, different address, different phone number, so on and so forth. That make sense? So let's say that you're a company that has 100,000 customers. And you're looking for Dr. Smith. How are you going to find Dr. Smith? Well, you're going to have to go to your customer record, customer file, read in all of the files. I mean, you can decide if you want to do this on the fly, or if you want to read it into an array right when the program loads. Let's talk about the pros and cons of that. So let's say we're storing all of our customer records in a file. So we have 100,000 customers, 100,000 lines in our file. Each line looks like this. Well, I have two choices. Every single time I search for a customer, I can go open that file, read in line by line by line by line, parse out that string, look at the name, and say, is this Dr. Smith? If it is, found his record, bring it up on the screen. I could do that one way, and then if 2 minutes later we're looking for Mary Kay, is that a cosmetic thing? Is it okay? We would open the file again, read from the file, blah 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 blah, write it and find our answer. That's one way we could do it. Every single time we were going to do a search, we'd open the file and search through the file. Another thing we could do is when we first launch our program, maybe we take the entire file, read it in, break it up into its individual pieces, and store a whole bunch of customer records in memory. The memory of your running program. Which is better?
Depends what you're trying to accomplish.
Okay, give me a scenario for each.
So the second one, store in memory, and you break everything, you go to the beginning. You're going to do a lot of searches that would be useful.
Okay, so storing stuff in real memory would be beneficial from a performance perspective if you're doing a lot of searches, by our example. Okay, what's the downside?
That one takes up a lot of memory, especially for Windows.
Yeah, it takes up a lot of memory. Now, just quick caveat, do you think probably when we were storing everything in files, we also probably had less memory?
Yeah.
Because storing things in files, being our main way of storing stuff, seems like it was a very old school way of doing things by today's standards, right? We have all sorts of new ways of storing pieces of information. So if we were storing something to a file, we were probably doing that during a time period where memory was expensive. Therefore, we probably didn't have tons of memory. And reading 100,000 customer records in and storing it in memory maybe wasn't the smartest thing to do. Okay, so the alternative, though, was reading it from the file every single time you search. What's wrong with that? Well, what's right with that?
It doesn't waste a lot of memory.
Doesn't waste memory at all. most memory we're using is one line at a time. But what's bad with it?
You'd be waiting forever to search every time you click the whole file.
Okay.
Or load the whole file.
Specifically, it's going to take forever. I mean, yeah, you're repeating the search over and over and over again, but file I/O in and of itself is extremely slow. Opening a file for reading causes you to load that entire file into memory. Then you read the file one line at a time. Well, actually, you're reading it one byte at a time, but we can just think about reading it one line at a time. And then you have to make sense of what it is. So, which is the right call? Still goes back to it depends, right? Okay. Would you agree that that doesn't sound like the best solution in the world? This whole file thing. There's a reason why we don't do everything with our dry erase board. There's some limitations. Right off the bat, we had one limitation with our file structure. What was that? If we wanted to look up a customer, we had to search through whether we had read it all into an array or we had left it in the file. We still had to search through and find the person linearly. Is this the person? No. 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 Over and over again. So if you're the person who is coming up with newer, better ways of doing this stuff, what might you do? What's the next approach? Could you alphabetize your customer record? You could do that. If you had it alphabetized, maybe off the first letter of their name in these kind of strings, since we're kind of at the mercy of how we're storing our strings here, right? We got this comma delimited crap here, so we lucked out that name at least comes first. So we can alphabetize based on the first initial, based on the name. Okay? So now they're in a certain order. That's going to take extra time at some point, right? Keep in mind, let's say you add a new customer. You have 100,000 customers. So now you add your 100,001th customer. So what do? Read in the entire file into an array. Figure out where in that array you need to add your customer. Then overwrite the entire file with the contents of your array after you add the customer to your array. So essentially, to add one customer, you had to rebuild your entire customer record file. These things really happened. This is how it used to work. Okay, so, and that was the better way. It's like, well, at least we could search faster. Search more better. Got it? Count that. Okay, we could search more better. So, we fixed the search problem, but now we hurt the storage problem. It's this constant balancing act. So now we go to more power tools. So kind of back here, at some point we needed to make the move away from flat files and towards something else that kind of gave us the best of both worlds. And that's where databases kind of came in. Now, it's not incorrect to view a file as a database. I don't think that's innately wrong. But semantically, I don't think you should think of files as databases. Database should give you this feeling that it's something more powerful. There's something more powerful going on. So a database, the common databases that we're going to be looking at in here, because over the next couple of weeks, we're going to kind of finish up this dice roller thing probably on Monday, kind of tie up the loose knots there. Then I want to start a project. I'll tell you about the project on Wednesday, but we're going to actually look at storing some things locally and then what things might we store in the cloud. Okay, and we'll talk about storing things in the cloud and how that changes things. Okay, but a database, I'm just going to say most of the databases, when somebody says, oh, we use a database, is going to be a relational database. So what a relational database is, it's a bunch of tables that are related or that have fields that are related to each other in some way. That make sense? So what a database tries to do is it tries to not duplicate data. So one of its goals is to minimize the space used by your data. And these are things you talk about in, how many of you have had the database class? Okay, these are things you talked about in there. Okay? Now, what a database also gives you, the other side of the coin, because today's users, we don't really care about how efficient it is at storing crap, right? We got tons of space. We don't care about that anymore. We used to care about that. Now what do we care about? We care about the ease of getting data out and putting data in, right? So when we think about databases, we also want to think about there being some sort of query language. Language. Is that it? Yeah, ish. Man, language is such a hard word. You would think they'd make that an easier word, since that's like the starting point. You know what I mean? Like, how can you talk about different languages if you can't spell language?
How would you spell it?
Well, no, I could spell it. I just have to think about it. I'm not that bad. I'm like not like Dane. I believe that, actually. He has to be good at something. It's not skiing. All right, so we need some sort of query language. And in most of our relational database languages, it's called SQL, structured query language. Okay, and we'll be looking at some of this. And keep in mind, this is not an SQL or a database class. So I'm going to be showing you the very simple case of writing something to, reading something from, don't ask any more questions type of examples for, because we're focused on iPhone app stuff. Okay, but we do want to think about when we're writing any software, specifically iPhone apps, what is the best tool for the job when it comes to storing things? Okay? So when we hear files, we want to think about simplistic storage. When we hear databases, we want to think about powerful storage. All right? So databases give us the ability to store lots of information at a granular level. It allows us to put information in maybe less easily than you could put information into a file, but more efficiently than you can put information into a file. And there's two levels of trust there. When we think about a database, most of the database books, they draw a little database there, and I'm probably not going to be able to pull this off, but we'll just pretend. They usually have a cylinder. They show a cylinder that's the actual. This is the actual database. This is the database management system. So the database talks to a management system, and then you have, the management system talks to the database. Then you actually have your user. Make him a triangle. Then you actually have your user that talks to the DBMS in some way. So in most of our languages here, the user talks to the DBMS through a language called SQL. All right? So the user uses a language called SQL, which talks to the DBMS, which magically knows how to read and write stuff to the database in what we hope is smart ways. as opposed to a user talking to a file. When a user talks to a file, they're in charge of everything. Well, here, actually, let's put all the pieces in. This will help the operating system crew too. So this would be the difference. In a database, the user uses a tool, uses a language called SQL to interact with the database management system, which is a piece of software. So like, for example, MySQL or Oracle or Microsoft SQL Server. These are database management systems. The database management system is a piece of software that defines how it actually talks to its database. The database, it stores somewhere on the file system and interacts with the database using the hooks that the file system has provided. Probably reads and writes. Does that make sense? So what's happening in here is no different than what's happening over here. Except what happens over here is the same for every single user who uses this specific DBMS. Over here, this is only the same for this one user. Because the next user might write things to the file differently. They might decide to use colon-delimited stuff. Or they might decide to store it as XML or JSON. Or put one value per line. Things like that. There's no standard over here. So there's no standard in terms of the format you're storing stuff. There's also no standard on how things get stored or how things get retrieved. So this programmer might be very slick and they might retrieve stuff in a very efficient way, or they might be the worst programmer in the world and might retrieve stuff in the slowest way possible. It's like, I like to read the file through 50 times just to make sure I got it right. Then I close the file and open it one last time. I like to have a little time to go to the bathroom while my program's running. Okay, so there's no standards over here. With the database, we have a standard. The standard's set up by our database management system. So it's, do we trust Oracle? That's how you judge those. Oracle is a big boy database management system. It's expensive. It's what companies like Amazon and eBay would use. It's fast. And it's expensive. And it has a lot of tools that allow the user, the programmer, to do very powerful things, store very powerful pieces of information, put together very powerful queries that are very, very high performance. MySQL is the database we'll use in here. It's fine. For most of us, if you were to write 100 different database applications, 100 applications that require a database, I would say that significantly less than 10% of those applications, you would see zero performance difference, whether you used Oracle or you used MySQL. You're only going to see it in situations like an Amazon or an eBay, things that are having thousands and thousands of transactions per second. Not, Bob's online hairspray store where you have 2 orders a month. Okay. Those read writes are going to be fast enough. Okay? You're not having to deal with making 5 million users happy within the same 20-minute period. That make sense? But from our perspective, SQL is a standard. So once you know SQL, you can interact with an Oracle database. You can interact with a MySQL database. You can interact with the Microsoft SQL Server database. Because SQL is SQL. Now, Some of the database management systems have what is like a superset of SQL. They may add a few commands to SQL that are proprietary to that specific database. But to retrieve stuff, you could write the same SQL statement and it'll work on any the same common SQL statement. It'll work on any of those databases. That kind of makes sense. So at some point, we trusted a smart person to write this database management system, and somebody else wrote SQL, and the database management system was written in terms of SQL, and we trust that whoever wrote this database management system did the interaction stuff with the file system good. Okay, they did it well. That way we don't have to figure that problem out. We can just say, write this, or give me that. And it's fast. Hopefully it's as fast as it could possibly be. But if not, maybe on average, it's as fast as it could possibly be. Something like that. Maybe under certain circumstances, a programmer could write it quicker because they know the nature of their data. But maybe a database management system writes it in such a way that retrieving the information on the common case, the average case, is always pretty fast. Can that make sense? Where when we get over here with the user just interacting with a file, we have no control, no holds barred. Just do whatever the heck you want. Is this a problem? Sometimes no. How many of you have dry erase boards in your dorm room or something? At least a couple of you. Do you think you both write stuff on your dry erase board in the exact same way? Some of us might divide it up into thirds, and the left third is for this stuff, and the right third is for this stuff, and the middle is for something else. Other people, they might just write everything just randomly. I could see Dane just be a random writer. It's like, look, wherever there's empty space, and I'll remember I put it there. That sounds like you, right? See,
I'm too lazy to write on it.
I'm too lazy to write on it, and frankly, there's better things to spend my money on than a dry erase board. So, but the point is that no two different people or 10 different people are likely going to have very different ways that they utilize that same tool. So there's no standard. And the thing is that the dry erase board works for you, right? You can make it work for you. So there are simplistic problems where this model is perfectly fine. What's nice about this? Well, because all of our programming languages already have mechanisms in them for reading and writing files. I don't need to go and set up a database, create a table structure, write the connection pieces to talk to the database. I don't have to do all that. Sure, this guy's going to give me the ultimate experience. If I'm writing things 10,000 times a minute and I'm storing 500 different types of things into the database, this one-time setup might be worth my time. But look, I need to store a couple of dice rolls. I don't need to go build a mansion to do that. I'm going to go outside, and I'm going to find a cardboard box. And I'm going to throw the dice rolls in there. Okay? But we would like there to be some sort of standard if possible. Okay? Because even this is hard. Because as the user, we have to decide how we're going to represent our data. Correct? So the man in the middle here would be a user which talks to NSUserDefaults, which talks to the file system, which talks to the file. I don't even know why I tried to preserve that over there. Deal. That makes sense? So we don't even have to deal with opening the file. All we have to do is grab our instance of NSUserDefaults and read and write stuff to it. And what kinds of stuff are we reading and writing to it? The same kinds of things that we're already storing in our programs. Objects, and arrays, and integers. That seems to be pretty convenient, right? Like in between runs of my program, I need to store some of the current state of my program. And the current state of my program is stored in terms of strings and arrays and integers and objects that I created. Okay? Well, here's a tool that'll allow you to just write that crap. No harm, no foul, right? Now, as users, do we care how this stuff was stored? We care that it got stored. And we care that it can come back. And last time we looked at, we need to understand the, kind of the nature of how it solves that problem. We needed to know, okay, when I write to it with an array, seemingly when my application loads, it reads in from NSUserDefaults. If I grab that array, it creates a brand new pointer, fills it up with that array, and then I'm using that during the duration of this run of my program. But when I close my program, the array in NSUserDefaults is unchanged. The only way it's changed is if I wrote it back and synchronized. But then the next time I open up my program, I'm going to get a new pointer. It's creating that actual array object each time. That make sense? All right, so we care that it works. And we do need to know a little bit of its idiosyncrasies in order to kind of make the world go around. All right, but in any case, as computer scientists, we may be interested in how it works. What NSUserDefaults does just like building sandwiches here. It's just like a filter. Okay? What NSUserDefaults does is they take a structured language, a standard language. The one they use is called JSON. JavaScript object something. Whatever. JavaScript object notation. That's what it stands for. 99.33% positive. JavaScript object notation. So what they do is when you write something to NSUserDefaults, it takes in that object and it has to convert it to JSON. Now I mentioned this at the end of last class, but this is something built into iOS. So what they've actually done is all NS objects in iOS know how to give you their JSON format. So they can convert themselves into JSON, which is just a textual format. So an object can say, this is what I look like on paper, regardless of how complex that object is. Isn't that kind of cool? So you can turn anything, well, let's just qualify that and say most anything, into a JSON string, which we can then store in our file system onto a file and read it back in. That makes sense? So NSUserDefaults is our proverbial modern way of writing to a file, but with some standard that we don't have to worry about the JSON, we just worry about working with objects and primitive types like we are already used to doing with as programmers. That makes sense? So I want us to have that distinct understanding. There is a difference between file I/O and writing to a database, and it kind of goes with power and flexibility. Okay? So we'll come back on Monday. We'll finish up our dice roller, DLE Flippy. I'll explain what our next project is, and we're going to start looking at some SQL stuff too. All right? I'll see everybody on Monday.